revisions. So hope you're all enjoying the Vedic mathematics session, right? Right. So just I had seen one message yesterday we were discussing. So it will be good for revision also. 23538 divided by 63. Generally, we write in this process. So yesterday we did it in one line, but today onwards we are going to little change because later on the things will be going to be little difficult. So it is important to write the things in this fashion. So till the time you are accustomed to this, right? So I prefer to write in one line, but as the complexity increases, it is very difficult to do in that fashion. So, so I prefer here, this is the right point. Till this point, you should be very sharp enough. You can do those things in one line. Now, we will use this type of pattern where the question is 23538 divided by 63. So this is the main dividend line. This is the main dividend line. And this is the adjustment line. Adjustment of units place. So whatever the units place adjustment there is there. So that units place adjustment we are going to do in this place. In fact, other than the highest value, Lakshmiji, just I had invited you in this class. So it is basically on divisions. We are discussing on divisions, right? So how to do the divisions and all, big divisions and all. So it is just it's just a lecture, right? It's a 6 days webinar. So just I had invited you to just watch, right? Okay, so anyhow, we had completed 2 days here. In this, the question is 23538 divided by 63. And then in this zone, we are going to write the remainder adjustments. So we have to be clear. So in the partial remainder, when we are dividing it by 6, we will get some remainder. That remainder adjustment remainder multiplied by 10, right? So that we are going to adjust here. So knowing that, and then there is one more dotted line I want to make it. So this is the line for demarcation of quotient and remainder part or decimal part. Whichever way that you take, it will be the quotient and remainder part or decimal part. So again I'm explaining 23538 by 63 is there. 1 second. So in this, we are going to write in this fashion 23538 divided by 63. So because one digit units place, we are taking it as a flag digit. So one digit before we draw a dotted line that demarcates our quotient and remainder. So whatever the first dividend, the partial dividend, this is a partial dividend line. You can note it down, partial dividend. And this is partial remainder. So partial remainder that is there, that will be adjusted here, right? So this is what we are going to do, and one digit we leave it for this, and this is the adjustment for the other than the partial divisor that we are using 6. Whatever the digits is there, the adjustment of these digits will be here. Okay, so I hope everyone is clear till this point, right? So again and again we are going to do this. So remember this just like that. And then in the first step, in the step 1, we are going to divide 23 divided by 6. 23 divided by 6. So here 23 we take, divide with 6. So 6 twos are, so 6 threes are 18 and 5 remains. So 3 is my quotient, 5 is my remainder passed as 50. And this 3 and this 3 will be multiplied and passed it here as 9. So here we are going to change the sign of it. So 55 minus 9, 55 minus 9 is 1 second. 9. So my quotient is 3, remainder is 5. So quotient 3 I am writing here, remainder 5 is passed as 50 here. And then this 3 times the quotient 3 times the flag digit 3. This we call it as flag digits. Right? So this is the thing. I hope everyone is clear till this point. Yesterday we did this, right? So 55 minus 9 is 46. 55 minus 9 is 46. So now we are going to the second step. We are going to divide 46 divided by 6. So 6 sevens are 42, 4 remains. So 40, 6 sevens are 42. 6 sevens are 42, 4 remains passed as 40. So now here in this case, let me write it with other color, 740. In the second step, we have 46 divided by 6. We are taking the quotient as 7, remainder as 4. 7 is here, 4 is passed as 40. Now 7 times 3 is adjusted here as 21. So 43 minus 21 is 22. So in the third step, we are going to divide. In the third step, we are going to divide 22 divided by 6. So 6 threes are 18, 4 remains passed as 40, and 3 threes are 9 again is adjusted. So 48 minus 9 is 39. So this is how, this is the final, this is my quotient and this is my remainder. I hope everyone is clear with this. So we'll move on to the next step. So those who wants to note it down, just I'm giving few minutes time, they can note it down, right? So remaining people in between, I want you to, those who are already well versed with this, they can try this problem, right? Six two four seven divided by 92. Yeah, till here I am writing for you, and then rest of the sum you have to do it, and you can write the answer in the chat box. Those who are attempting on the right hand side, for those who are new, they can note down the left side problem. It is very important where we are writing, how we are writing. It is very important, the adjustments and all those things. I hope everything is clear. Good time to note down. I think this much time is enough. Let us move ahead. Right? So the right side solution I had provided, and already somebody had written the solutions. So 67 is my quotient and 83 is my remainder. Here when 62 is divided by 9, 9 6 are 54, 8 remains, passed as 80. And then this 6 and this 2 is multiplied here. So it is 84 minus 12 is 72. If I'm going 9 8s are 72, I observe that 8 2s are 16, I cannot subtract. So because of that, I taken as 9 7 63 90 passed, and then 97 minus 7 2 is 14. So 97 minus 14 is 83. I hope everyone is clear till this point, right? Good. I'm clearing all the drawings. Let us move ahead. Now, yeah, again, one more problem we are going to take. Anyone can give me the number, or I will take randomly any number. 4 7 3 5 2 divided by 78. Right? So whenever 78 is there, by observation, we write it as 82 bar. This means 80 minus 2. This is 70 plus 8 or 80 minus 2. We represent in this fashion. And then we are going to divide, we are going to write in our place 8 minus 2. Right? So now we are going to leave this one place. First number is 47. So as I mentioned you yesterday, whenever the remainder is bigger and then you are going to add something, it may cross your divisor. So here, if I'm going to write 5, it is going to cross my divisor. Suppose, for example, if I'm writing 8 5s are 40, 73 plus 10, 83, but my divisor is 78. So by observing that, I have to adjust here and take 8 6 are 48. 8 6 are 48. So then minus 10 is passed. So this is again plus 3 plus 12, because here already is negative. Whenever it comes inside, we will change the sign. As the flag digit, as this box, we are going to change the sign. So either you can write it as bar 2 or whichever way. So 6 times minus 2 is minus 12, but minus of minus 12 becomes plus 12. So my number is simple 5, because it doesn't go, right? So 50 will be passed and then 0 is adjusted. So 55. So here also we observe it is very near to 7, right? So 8 7s are 56. So my observation is whatever the remainder, if it is greater than, in case of negative flag, if it is greater than or equal to greater than half, I'm more cautious. So in this case, the remainder is, in this case, when 55 is divided by 8, my remainder is 7. So I have to be very cautious. This 7 is greater than 8 by 2. The chances of exceeding the divisor is more. So what I'll do is 8 7s 56. Right? 8 7s 56. So minus 10 is passed and 7 times 2 is 14. So final answer is 6. So my quotient is 607 and remainder is 6 here, right? So if I want to check with the digital root, last time, before last class, we learned about the digital root, right? So now I'm going to check with the digital root. The digital root of 8 minus 2 is 6. The digital root of 607 is 4. Anyhow, single digit 6. So now it goes like this: 6 times 4 plus 6. So 24 plus 6 is 30, which is 3. So here 3 should be my digital root. Let us check. 549729. So 3 mapped to 3. So my answer 607 is quotient and 6 remainder is the correct answer. Right? I hope everyone is getting this. If you have any difficulty, you can raise your hand and then we can discuss. Right? So now you can note it down, right? So those who don't want to note it down, or those who had completed, for them I'm going to give you the similar problem on the right hand side, right? Those who are noting down the left side, it is very important to note down step by step while writing. Please don't see the board and write it. Do on your own. And if at all you are going wrong, then you can verify and see. The two rules for learning mathematics. Don't forget. The first rule is when I am teaching, you need not write. You just observe what I am teaching. Just observe. Right? And when you're writing, the second rule is when you're writing, you should not see the board. Right? 7 5 is 35 minus 10, 15 is added. 21 minus 10 is 11. So 7 ones are 7, 40 passed, and then 3 is added. So 40. So 51 is my quotient and 45 is my remainder. 51 is the quotient and 45 is the remainder. I hope everyone is getting this, right? Good. Let's move on to the next one. So here, before going ahead, I want to tell you something like vinculums. So whenever the bigger digits is there, so to reduce it to smaller digits, we are using the concept called veniculums, right? Hare Krishna, we are going to discuss similar type of problems. Don't worry, right? All divisions only. So if at all any particular difficulty is there, we will discuss after 7 p.m., right? So in case of veniculums, let us say if my units place is bigger or any bigger digits are there, if I want to convert into smaller digits, so the rule is take the complement of the number and add 1 to the previous digit. Suppose if my number is 78, if I want to convert this part, I take the complement of this part and add 1 to the previous digit what we are doing it. So this becomes 8 and 2 bar. So this type of number is called Veniculum number, where in the same number we have some positive digits and negative digits, right? So suppose if my number is 389, so I want to change this number. So I'm going to take the complement of it. So many of you might be knowing about the complements. Otherwise, I will teach you. It is very simple concept. All from 9, last from 10. So this is the rule. Just I'm telling you. The rule is all from 9 and last from 10. That means if 89 is there, all the digits, even whatever the big digits is there, only other than the last digit has to be subtracted from 10. Remaining all digits should be added to 9. So 8 plus 1 is 9, 9 plus 1 is 10. That's how I'm getting the complement of this number, right? Suppose if my number is, let us say, for complements I'm talking about, here let us say 678. So these two digits are added to 9, the last digit is added to 10. So my answer is 322, right? 5976. These three digits to 9, last digit to 10. So 4023. Sorry, 4024. The last digit is to 10. So you have to add such that you are getting 10 here. I hope this concept is, many people know about this concept, and then I'm going ahead. So the concept's rule is, whenever the number is there, if whatever the digits you want to change, you take the complement of those digits, put the bar on them, and for the remaining digit, the previous digit to that, you have to increase 1. So that is the rule for that. Okay. So let us do some Veniculum numbers. 379. I want to convert both the numbers, whichever number that is greater than 5 apart from the leftmost digit, right? So the leftmost digit I am writing here, wherever this cannot, this, if this is greater than 5 also, we will retain. Remaining all digits we are going to retain, like for this it is 4, 2 bar, 1 bar. So 79 complement is 21. This will be increased by 1, right? Here only this you have to change. Here all the digits are bigger, these things you have to change. Do it in your notebooks, you can do it. Simultaneously you can do it. So these are very simple concepts, so you can write it in your notebooks. Or because here writing the bar numbers is difficult, you can put bracket and write it, like the one that I'm writing for 4 bracket 21 bracket. So like this you can write, but it's okay. If you are having book, you can write it in your book also. No need to write it in the chat box. So I want everybody to write the complements for these numbers. Veniculum form of the numbers for these. Where the circled ones, I want you to write the circled ones as lesser than 5. The number should be less than or equal to 5. So in that format, I want you to write it. Okay. Now I'm writing for you. So it is 7, 2 becomes 3. Only the number this is changed. So 2 becomes 3 and 2 bar here. So here all things are changing. So I'm changing 6 here. So 5 becomes 6 and 6, 7, 9 becomes 3, 2, 1. Right? And here 3 becomes 4, 7 becomes 3, complement. Again, when we are doing, again we have to increase 3, 2 bar. Here it becomes 9, 2, 1, 2 bar, 1 bar, and then this is only 4. There is no bar on 4. So you have to be very clear. All the digits should be less than 5. Right? I hope this concept is clear to everyone. So when we want to go back from here to the normal number, so what we are going to do is whatever the bar digits is there, again we take the complement of this number and reduce 1 from the previous. So this becomes 3. Before taking the complement, whatever the previous digit is there, we reduce that by 1, 4 becomes 3, and 21 complement is 79. So 379 is my number. Here 7 written will be written as it is. The before digit is 3 becomes 2, and then 2 bar is 8. Similarly here 6 becomes 5, 321 is 679. In this case 4 becomes 3 and 3 is 7, 3 becomes 2, 2 bar is 8. Here 9 becomes 8, 2 1 bar is 79 and 4 is 4. So how to write the negative numbers, Veniculum numbers and convert back to normal numbers. So the Veniculum numbers are also called in Sanskrit as Mishram. Mishra means it is a combination of positives and negatives. Right? So in Mishrank, right? Ank means the number and Mishra means it is a combination of positives and negatives. Different types of numbers are there, right? So generally we call it as veniculums. So you can easily remember and you can do the things, right? I hope I'm clear till this point, everyone, right? So let us move ahead to our problems. Now we are going to increase the number of digits in our divisor. Yesterday we had seen only 2-digit divisor. So today we are going to deal with more than 2-digit divisor. Let us say my number is 4369 divided by 523, right? So as usual, I will write in this format 5, 2, 3, and then before 2 places I will draw a line because here we are leaving 2 digits. So here also we will leave 2 digits. I hope I am clear at this point. So this is my quotient part. This is my remainder part. So what I do is first I will take, because 4 doesn't go, so I will take 43. So 5 8s are 40, 5 8s are 40, 3 remains, goes as 30. I hope everyone is clear till this point. After this, 8 2s are 16, that is you have to subtract here because inside it is changes. 8 multiplied by 2 will be written next part, 8 multiplied by 3 written next to that part, that is 2 bar, 4 bar. Okay. Now here observe carefully, here 36 minus 16, 36 minus 16 is 20. So we retain 1 and then pass the remaining digits. We retain 1. Out of 20, if it is a 2-digit number, we are going to retain the units place, tens place, and pass the units place to the, just like the previous way that we are doing. And then here minus 2 is there. 9 minus 4 is 5. 9 minus 4 is 5. 0 minus 2 is minus 2. So, but we know how to change the runank to normal number. So, this will be 185. This will be 185. So, 2 bar, just now we learned that how to change these numbers, right? So, there are two ways here. Instead of writing 2 and passing 0, the 20 is there. So we had written 2 here and passed the 10. Okay, so this 20 can be written as, we can retain the other color I will take here. So the other way around I can do it is, here I can write 1. This is 10 plus 10. So 10 is my tens place digit. So I will keep 1 here out of 10. And this 10 is passed as 100. So this way also you can do it. So 10 minus 2 is 8. And 9 minus 4 is 5. So different ways of getting it. But both ways you are going to get the same answer. With this blue color as of now, we will learn only one thing. Don't confuse. You can note it down. We will do one more calculation on the right hand side, so that people wants to note it down, they can note it down, right? So when we are doing the division process, 4369 is divided. I'm repeating this. When 4369 is divided by 523, we write in this fashion. We are going to divide it by 5. First number is 43, drop down as 43. When 43 is divided by 5, 8 is my quotient, 3 is my remainder, passed as 30. Now, in the adjustment line, I have to write two numbers, because here 2 flag digits are there. So 8 times 2 is 16, 8 times 3 is 24. Both are negative numbers because both are positives on the left hand side. So when it goes inside, they becomes negative. So 36 minus 16 is 20, 2 0 passed. And then here minus 2 5. So this can be adjusted as 185. Okay. So those who wants to note down, please note down this question. Others, they can try this. So you can do on your own on the right side now. Those who had finished already the left side or understood the left side and they are very clear, they can try with the new problem. The same concept with the new problem, they can do it. So here 6 goes 5 times, 6 5 is 30, 4 remainder as 40, and 5 3s are 15, 5 2s are 10, right? So here I'm doing with the other method. 45 minus 15 is 30. 30 I'm writing as 20 and 10, 100 in this format. So whenever 30 is there, I can write this as 20 plus 10. So out of the 2 I'm writing, this 10 is passed as 100 here, right? So both ways of writing. Here you have to again adjust. In this case, you need not adjust. So before foreseeing that there is something negative here, it is adjusted, right? So 110, 107 minus 10 is 97. So 5 is my quotient and 297 is my remainder. I hope everyone is clear with this, right? Okay, let me take to the next step. Can I clear this? So let me take to the next step. So here my number is, let us say 4375 divided by 789. So here it is very important to change this to 8 1 bar 1 bar because we don't want any bigger digits here. So to avoid the bigger digits, we change it into Veniculum numbers. So my concept will be 8 1 bar 1 bar. 2 digits here and then 43, right? So here the thing is very clear. 8 5 are 40, 3 remains as 30, 5 ones are 5 and 5 ones are 5. Because this is a negative number outside. When it comes to inside, it is a positive number. So here it is 5 ones 5 and 5 ones 5. So the two 5s are written here. This one is this, and then when this is multiplied, this is right. So 37 plus 5, 42, 420 passed. And then 20 plus 10 is 30. So 430 is my remainder, 5 is my quotient. Now I want to check whether the sum is right or wrong. So how do I do that? Using the digital root. So 8 minus 2 is 6. This is 5. This is 7. 6 5 is 30. 3 plus 7 is 1. So this is multiplied here, this is added here. So 30 plus 7, 37, which is 1. So 5, 4, 9, 7 plus 3, 10 is 1. So my answer is correct. Whenever foreseeing the adjustment, I will come to this, Ravinder. Whenever it comes, then we will discuss again. We are going to get some places, right? So we'll discuss. Otherwise, we'll discuss at after 7 o'clock. Okay. So now the next problem. And now even we can go for the any number of digits on the right side, 3 digits. So let me take little bigger problem. 5, 3, 2, 4, 6 divided by 8, 1, 7. So in this case, I observe that only 7 is bigger. So because 8 I'm going to divide, this can be bigger, no problem. This 7 is bigger. So I change it to 8 2 3 bar. So my number is 8 2 3 bar. So observe very carefully. Here we are going to have a 2-digit quotient and whatever the remainder, because 2 digits I'm taking apart, right? So 1 digit is going to be positive, other digit is going to be negative. So we will leave enough space so that we can write 2 numbers here. There's one in the first line, other in the second line. So that 2 digits are there, which can be adjusted accordingly. right? So here, when we are doing this, 58, 53, the first divisor is 53 divided by 8. 8 6 are 48. 8 6 are 48. So So here we take 6, 8 6 are 48, 5 remains passed as 50, right? So this is multiplied and we are going to write 6 2's 12. So 1 bar, 2 bar, right? 6 2's 12 and 6 3 is 18. So this is positive 18. So I'm not changing this, right? So the first step, I hope everyone is clear. In the first step, 53 is divided by 8. And quotient is 6, remainder is 5, and 2 and 3 are adjusted accordingly, right? So in the second step, 52 minus 12. 52 minus 12 is 40. So here if I am writing 5, I have to make sure that this should not be a negative number. But here already 18 is there. So I'm least bothered. So I can write 5 here. 8 5 is 40. Now this 5 is multiplied with 2, 10, which is a negative 10, and 5 3 is 15, which is a positive 15. So here my division ends where my quotient is 65, and 40 is divided by 8. So 5 is quotient and 0 is remainder, right? So 18 plus 4, 22 minus 10, 12. So retaining 1, out of the 12, I'm retaining 1, passing 2 as 20. So whatever the 2-digit number, we retain only 1 digit. We are not going to divide anymore. We pass that digit to the next place. So 2 plus 1, 3, plus 1, 4, 141 is my remainder. 65 is my quotient, 141 is my remainder, right? So here if I observe the digital root for this, if I observe, so this is 7 here, this is 6 plus 5, 11, that is 2 here, and this is 6 here. So 7 2s are 14, 5, 5 plus 6 is 11, 11 is 2 again. So here it should be 2, 5, 4, 3, 6, 2 matches. So my answer is correct. So those who wants to note it down, please note down this sum, and those who wants to try with different number, those who are very confident and they know it, please they can solve the problem that I'm giving on the right hand side. The left side one is important for all. I want everybody should understand this. This is for those who are who wants to do something extra. I hope this leads to little complexity, but if you're clear at the initial level, then it is very easy. The concepts will be very easy, right? Hari Krishna has raised his hand. Let me see where he is. Pick up the numbers. Hari, I am asked. I can unmute you, or you have to unmute yourself. So, yeah, Hari, if you have any question, I can unmute you all or unmute all. Okay, let me unmute all. We have only 10 minutes. Can I take the question, Hari, in the later part, or is it urgent to take it right now? So if you can ask me later also, we can go ahead and solve the questions in the end of the session after 7 o'clock, right? So that will be easy for us. If it is very concerned to this particular thing, and if you're not very clear, then we can go ahead. Okay, thank you. So I hope everything is clear. Everyone is clear to this point, right? So good. So far, so good, right? So now we are going to discuss today, only 8-10 minutes is there. So let us discuss one or two problems. Now I'm going to take the problem where 327 is divided by 59. Okay, so 6 1 bar, but I want 2 decimal digits. The rule is I want 2 decimal digits. So, and the second decimal has to be approximated, right? So 327 divided by 6 1 bar. So I will place the decimal digit wherever my remainder line is there. I will place the decimal digit, and I will continue with imagining the decimal is here, and then I continue with it. That is the simple thing. That's it. So I'm taking 32 here. So 6 5s are 30. 2 remains, passed as 20. 5 1s are 5 is adjusted. Again 32, right? So 6 5s are 30. 2 passed, 20. 5 1s are 5, right? So here I'm getting 25. So 6 4s are 24. 10 passed, plus 4, 14. So here once I observe the 14 is more than half of 6. So if I want to approximate, I approximate this as 5 5. No, 1 second. If I am dividing, sorry. If I am dividing this, it is approximated as 5 4 only. If this is more than 30, right? Then we approximate this as 5. It is very much approximation, but it is very close. I don't say that it is correctly. If you want correct answer, you have to go for the next step. But approximately, if it is less than 30, if it is greater than 30, I have to increase this by 5. If it is less than 30. So 6 5s are 30. Because of that, I am taking. So the answer here is 5.54. So the digital root remains same. So the digital root is here 5. 554 is 5. And then 14 is, here the remainder is 14, right? So 14 is 5. All are 5s. So 5 5 is 25. 25 plus 5, 30. So 30 is 3. 7 to cut. 3 is match. So my answer is correct. I hope everyone is clear with this. Whenever the decimal digits are there, it is only you have to place the decimal as means first in the quotient digit itself, where the dotted line we are making, there we have to place the decimal, and the remaining quotient is same as normal the division we are going ahead, and increase the zeros on the right hand side, because you can increase any number of zeros. Right? So for those who had complete, who wants to do it separately, one more question on the right hand side. So you can go with this. I want 2 decimal places. Second decimal places has to be adjusted with the, means you have to observe. Although it hardly matters when we are taking the 14 as remainder, for digital root it is fine, but approximation, you have to just see that how you are approximating. I hope everyone is clear with this. So because we are adjusting here, so it is 8.69. Where is my whiteboard? I hope everyone is clear with this. For today, only last, yeah, we can stop it here. Almost we are done with all the decimals and all. So let us keep the remaining session open for the discussion, right? So people can ask, we can go for somewhere around whatever, any discussions, anytime, no problem at all. Anybody having any questions, please feel free to ask. I'm unmuting everyone, so you can ask the questions all. So those who wants to ask any question, please unmute yourself and you can ask the questions. Yeah. So only those who have questions, please unmute themselves and you can ask the question.
Sir, I am Hari Krishna.
Yeah, Hari Krishna.
Sir, I want to know 56428
56428
divided by 639, sir.
639.
Yes, sir.
Right?
Yes, sir.
So here the bar is there, 56 is there. So when I'm passing 20, I observe that 6 nines are 54 is much bigger than that, right? 6 nines are 54, 20 is passed, 9 fours are 36, I'm going to subtract here.
Okay,
So
okay.
because of that, I take only 8 and pass 80. So 8 fours are 32, that is a negative number, and 8 ones are 8, it is a negative, becomes
Sir.
positive here.
Sir.
So 84 minus 32 is 52. 8 6 are 48, because now it is 48 is there. Even 6 4s are 24 is subtracted. I am positive, right? So 6 1s are 6. So so here 42 plus 8, 50 minus 24 is 26, 2, 60 passed, and 68 plus 6 is 74. So 86 is my quotient and 274 is my remainder.
సార్ ఒకవేళ నేను 6 9 54 తీసుకుంటే ఎక్కడ అడ్జస్ట్ చేసుకోవాల్సి వస్తుంది సార్?
Which number?
సార్ 6 8 50 48 చేసుకున్నా కదా మీరు ఇక్కడ.
Yeah,
6 9
if you are taking 9 later on, you have to adjust. That becomes little more complex. I generally avoid that type of adjustment. You can adjust, means whichever number you want to write, I will write it and I will adjust it. No problem at all.
How to adjust, sir?
Hello, sir.
Yeah.
అది 8 కదా సార్? 8 తర్వాత మళ్ళీ 8 52.
Yeah. Sorry. Yeah. 6 8
okay.
48. Correct. Yeah. So, any more questions from anyone? Please feel free to ask. No. You don't write. I will write it for you. Please, you don't write it on the board. You tell me the numbers. I will write it for you. Any more questions from anyone?
Yeah, 3410 divided by 88.
Divided by 88. So we take as 9.
No. Hang on, sir. I'm not. I'm just trying to understand the algebraic logic behind this.
Okay.
If I take 88 as 100 minus 12, which
Yes.
is x square minus x minus 2.
Correct.
So the algebraic logic works. But if I take 88 as 8x plus 8, where my base is equal to x is equal to 10, the algebraic logic doesn't work.
No, actually here you are taking the same algebraic logic. See, here you are taking x is equal to 10, right?
Yeah.
So put 10 here. The algebraic logic is working. What are the quotients you are taking? 1 minus 1 minus 2. It is working. Why it is not working?
Yeah, but my base is 88 can also be written as 8x plus 8.
Yeah, that can be written in many forms.
But algebraic logic doesn't work. If I divide 3x cube plus 4x square plus 1x plus 0 times 1 divided by 8x plus 8, algebraic logic fails.
No. Actually, there may be two different ways of doing it. If I am taking 8x plus 8, my remainder will be a single, means constant number. Wherever my square is there, my remainder will be in linear expression, right?
Okay.
Right. So it is different. Whatever you are seeing, the answers will be different. Means here we are taking different form of x and doing the thing, and then here we are taking different form of x. We are doing anywhere you are changing the logic, it won't work.
Okay. Your approach has been great. I've been at it since the first class, and I know a little bit about Vedic mathematics, but my interest area is more like integral calculus and simplifying integral calculus.
Yeah.
I hold a master's degree in finance from London School of Economics, and I super simplify integral calculus.
Okay.
And what I try to do is I even go to the extent of when you have a use substitution, algebraic to trigonometric, why do we use those three trig identities, sine square x plus cos square x is equal to 1, and then tan square x plus 1 equal to secant square x, and cot square x plus 1 is equal to cosecant square x. The logic being that, derivative of sine is cos, derivative of tan is secant square, and derivative of cot is minus cosecant. So I try to get conceptually deep into, that kind of, relevant mathematics.
Yeah.
But here this logic was not working. I'm still trying to figure out. Yeah. But anyway, maybe you
sure.
guys...
We will also look into why, in what, because means we have to think in this direction, and we can sit separately as a,
sure.
We can have a small group.
Sure.
And then we can have some specific questions before discussion. and then we can go for the discussion.
Correct.
Surely I and many of my colleagues are very much open for this type of discussions. Surely means we can pose our problems the way that we can look into different angles. See, the beautiness in Vedic mathematics is the thing that I see is it's all about means you are seeing the things in different angles, right? The same thing we are observing in different angles and understanding the logics behind and seeing the things in different ways, right? So there are multiple combinations are there here. So we have to understand the logics behind this and then how we are working and all, so that in the later part of it, how we are simplifying the things and all those things comes into it. So as I see that if you means till the simplification of very simple linear equations and simultaneous equations and all, till that extent it is fine. But when it goes beyond that level, then we have to have a specific area of discussion. Surely means if you have some problems, some of the members in this can be joined with us. Also, I have some of the groups which are very good, have good idea about Vedic mathematics. We can discuss, and then that will be a discussion point rather than a teaching point.
Correct. Right? No, I will not take any further time of the group as well today. So we can do it separately. I'll maybe take your WhatsApp number from Charan and we can.
Sure, Vishal.
Thank you very much, sir. Your approach is fantastic. I really like the way you are building up things.
Thank you, Vishal.
You're welcome, sir.
So please feel free, everybody. It is not that only 2 or 3 persons are there. You might have many doubts. Please and come back to us if you have any difficulty. Check with the calculators, whatever the way that you are doing and all. So the more you explore, the more you enjoy, the more you learn. If you are just coming and attending the classes and going back, I don't think that it will be more useful for you. The whole exercise we are doing just to make you comfortable, enjoy the thing and practice more, right? So you will really, I'm telling you, you will enjoy more when you practice more.
Sir, one minute, sir.
Yeah.
Sir, in algebra polynomials division, we are making the divisor into modified divisor. So here also, can we change into modified divisor, sir?
For example, can you give me one question?
No, yes, this question only, for example.
Okay.
Here 9-2 bar is there. So divisor is negative here. So in that I will put direct changing into positive sign. For example, 88 is there. Then I will write in the modified divisor -8.
Correct.
Again, no need to change the sign in the dividend part.
See, it is hardly matters. See, all these things.
Can we take?
I think I've got the answer, because if we take it as 9-2 bar, then what happens is my divisor can be written as 9x minus 2.
Yes.
So I think I might get the same answer in the quotient again.
When it extended to means that's what when you are extending this to see if you are. I think if we discuss in this thing in a little algebraic format. So when the squares and cubes are there, so when you are increasing the power, see till the extent where you are not changing the degree of the equation, right? Maybe I'm not very sure. I never tried it really, right? So this may be my just engendered perception that if you are not
actually what happened is, sir, every algebraic proof అనేది ఇక్కడ మనకి prove అవ్వదు ఇలాంటి కేసెస్ లో కొన్ని సార్లు వే ఆఫ్ డివిజన్ లో తేడా ఉంటుంది, రిమైండర్ లో తేడా వస్తుంది. ఒరిజినల్ గా మనం నెంబర్ ఫామ్ కన్వర్ట్ చేయాలి అంటే రిమైండర్స్ రాసుకోవాల్సి వస్తుంది కాబట్టి వర్కౌట్ అవుతుంది.
Whenever you are changing one form to other form in case of algebra, in algebra we don't carry, means once the algebra thing is done, then it is better to discuss at that level, right? So we will take this type of questions and then we will frame it and then we will give it to you so that we can enjoy the algebraic division session, right? So today we completed the number part to some extent. So tomorrow we are going to see some algebraic part. right? And the day after tomorrow, the decimals and combined operations and all those things we will take care. So with that 5 days, we will have a very good idea. And 6th day, it is more of discussion, and then what are the other things that are remaining, that some special cases and all. I think that is a good line of approach that we can go ahead, right? So tomorrow is algebra, day after tomorrow is combined operations. This is 5 days, and the 6th day is sometime we can keep it as an open lecture, and for some time we can keep that as a special cases, like when it is divided by 25, 5, and some special cases like because many of the special cases are already covered in this, but even then we can see them as a special cases, and then we can work on, right? So in this way, we will go ahead for the next 3 days just to have an idea, right? So tomorrow we are going to discuss with the algebraic concepts of division, where basically just small thing, the difference maybe is the difference we do it is there is no passing remainder. So something is divided, we have to divide exactly. And this here you can have multiple numbers, right? So 302 is there, anything, x squared plus x plus whatever, right? So here you can have many numbers. There is no passing remainder, that should not be there. So it has to be exactly divided, and then we will go ahead, right? So tomorrow we will come up with some of these conversions and also, and let us see that how it is impacting the actual quadratic equation. And some other people may throw light. It is not that as a speaker I'm expert in this area.